Okay, 36. Let's see. Important that you understand this concept. First derivative, second derivative are both positive. Well, make sure you get this. F is a function. Then what does f prime tell us? F prime tells us the slope of f. F double prime tells us the slope of what? Think about it. Say it. Say it out loud. Good job. The slope of f f prime is the slope of the function you're taking the derivative of. F double prime is the slope of the function you're taking the derivative of, which is f prime. Does that make sense? Okay, so now we got to address this. If f prime is positive, that means the slope is positive. That means f is increasing, right? I'll say then. What if f double prime is positive? That means f prime, f prime is increasing. So the question really amounts to, do you know what it means for a function to be increasing and for the derivative to be increasing? Because they want both the first and second derivative positive everywhere. So for f to be increasing means it's going up. Okay? It's increasing, it's increasing, it's increasing, right? Think of the slopes. The slopes are getting bigger. Okay? Oops, what am I doing? Oh no, increasing. Sorry, that's increasing. But what's happening to the slopes on this one? They're getting smaller, right? So here's an example of f is increasing, but f prime is decreasing. That's what makes it concave down. Okay, if it's increasing, then that means it's getting steeper and steeper. This is concave up. Does that make sense? So if I want a function that's where the derivative is positive and the second derivative positive, that means it has to be, the function is getting bigger and the derivative is getting bigger. In other words, the slope is getting bigger. So we're going to be looking at that. So what about this? What would this look like? F prime is positive, f double prime is negative. This means f is increasing. This means f prime is decreasing or concave down. Okay, so if it's increasing and concave down, it's going to look like that, right? Because the derivative is steeper and getting smaller and smaller. It could also look like, well, let's look at this. F prime less than 0, f double prime less than 0. That means f is decreasing, it's going down. And this means f prime is decreasing or concave down. So it's decreasing and it's concave down. Right? Because look at think about the derivative. It's a small negative number, then it's a really big negative number. So it's getting smaller and smaller. It's getting larger in the negative direction, which means it's getting smaller. In the last case, f prime is negative, f double prime is positive. So f is decreasing, f prime is increasing. So it's concave up. So how could a function be going down, but the derivative is getting larger, or it's concave up? Well, what about something like this? The f is decreasing from left to right, but f prime is a big negative number, smaller negative number, smaller negative number. I say smaller, I mean smaller in magnitude. So the slope might be negative 3, negative 1/2, negative 1/10. The derivatives are actually getting bigger, right, as we move from left to right on the number line. Okay, so there's your relationships between all of the different functions and what they'd look like for f prime and f double prime. Okay, there we go on that one. Let's look at 38. Let me see what I got here. And I probably didn't copy that either. Doggone it, I am sorry. So basically what we're looking at here is f prime is equal to 1. So if f prime of x equals 1, That means the derivative is 1 everywhere. That means the slope of it has to be a positive 1 for everywhere between 0 and 4. F prime is positive just means it's increasing. Could be increasing linearly, could be increasing curved, either one of those ways. And these two just tell you the actual slope at 2. The slope at 2 is 1. The slope at 1 is 2, which would just be a little bit steeper, right? Okay, so we're good on those.